In the figure below, A, B, C, and D are collinear. FC is parallel to ED, so this line segment between F and C runs in the exact same direction as the line segment between E and D. BE is perpendicular to ED. All right, so they draw that this line segment B to E is perpendicular to ED. This is a perpendicular angle. It's a right angle. And the measures of angle FAB and EBA are as marked. What is the measure of angle F to C to B, which is this angle right here that they've drawn the question mark on? Okay, so one step to starting to answer this question is to realize that this angle with the question mark is the exact same angle as E to D to C. And the reason we know that is because the purple lines run in the same direction, they're parallel, and the black line, which makes up the base, runs in the same direction because it's the same line. Of course, it's also parallel. It's even more than parallel. It's the same line. All right. So anyways, we have the same angle here. So if we could solve for this angle, then we would know what this angle was. And the next thing that's a helpful fact is to realize that if we know the interior angles of triangle, they must add up to 180 degrees. And this is a useful thing just to keep memorized. But if we knew the angle, let me just draw in right here. If we knew this angle plus this angle plus this we knew this angle plus this angle, then we could figure out the final missing angle because we know they have to add up to 180. And we're already part of the way there because this blue angle, they said, is perpendicular, which means it's a 90-degree angle. And if you ever have trouble remembering that, I always just remember a circle is 360 degrees around, and a right angle or a perpendicular angle is a quarter of a circle. So 360 divided by 4 is a 90-degree angle. So we know that one. Now, if only we could find this little one, then we would be in business. If we could find this one here, then we could solve for our missing one. Well, solving for that one involves recognizing that a line is always 180 degrees. So this angle I'm highlighting here is 180 degrees. And if you ever have trouble remembering that, again, I always just think of a circle. A circle is 360 degrees. A line divides it in half. So 360 divided by 2 is 180. And if we know that, then we can figure out that the angle here represented in dark purple is equal to 180 degrees, which is the total angle of the line, minus 147, which is the part of that angle that's not part of the purple side. So 180 minus 147, this dark purple here is equal to 33 degrees. I can do in my head here. So this angle right here is 33 degrees. And so now we know two of these angles, so we can finally use our equation up here. So we know 180 degrees is equal to all the angles inside a triangle added up is equal to 33 plus this other angle, 90 degrees, plus the angle that we're trying to figure out, this angle that I've go ahead and labeled with orange here. So whatever orange is. All right, so now it's just a math problem. 180 minus 90 is going to be 90, and 90 minus 33 is going to be equal to let's see, 57 here. And you could use a calculator, of course. So 57 is equal to this angle over here, which is exactly equal to the angle FCB that we wanted. The correct answer is B.